Usually, when creating an augmented reality guidance application, a lot of preparation is needed. One has to carefully capture and label data required for modeling the individual object parts. Moreover, information about the order of assembling or disassembling the parts is needed for creating the tutorial. What if one could automatically extract all of these 3D instructions without prerequisite models, just by capturing unconstrained user demonstrations? We introduce a method that allows Model-free authoring and replaying augmented reality 3D instructions using only user-captured demonstrations as input. The actions are recorded using an RGBD sensor, which can be stationary, handheld, or head-worn, on top of an augmented reality head-mounted display. At our method's core lies a 3D scene reconstruction created by a TSDF-based SLAM system. We aim to detect when a significant change occurred in the reconstruction of the observed work area, captured by our designed volumetric change function. The function identifies large differences when object parts are added or removed. Furthermore, it extracts the volumetric differences as partial reconstructions of the individual parts. We show results on a range of objects, such as a coffee machine, a tower stacking toy, a wooden stool, and more. The extracted partial reconstructions can be merged with previous captures, also yielding information about possible branchings in the partial assembly graph of the object. We show the usage of the extracted tutorials in an AR guidance application that also uses the change function to trigger the next step in real time. The resulting instructions are replayed in augmented reality on the HoloLens 2. We display the 3D convex hull of the extracted parts along with status icons that indicate the next step, as well as validate the performed actions. We also show extracted video snippets of the assembly demonstrations for more detailed gestures.